It is important to be able to recognise the parts of a circle and whether each section is minor or major. For sectors, the minor sector is always the sector that has an angle x at the centre that is smaller than 180 degrees, and the remainder of the circle is the major sector. Putting that into practice, if I label this as x, this angle here is clearly under 180 degrees. This sector is minor. It's the smaller sector. That makes this sector, the remainder of the circle, major. We can also talk about the arcs that they contain. So for example, the arc from there to there, that section of the circumference, this is the minor arc. Well, what does that make the other section of the arc? The major arc. So remember, this is a sector. For segments, the segment that is smaller than half of the area of the circle is the minor segment. So looking at this diagram, this one is going to be the minor segment, and this one is going to be the major segment. Because the major one is bigger, the minor one is smaller, effectively. Each one of them is enclosed by an arc, and again associated with a name. So the arc from this point to this point that goes around our minor segment is called the minor arc again. And you guessed, same as on this diagram, this larger arc is called the major arc. To calculate arc length, you will always need the size of the angle at the centre of the sector and the circumference of the full circle. Effectively, if we know the angle here, we know what fraction of the full circle this sector takes up. So from there, we know that the circumference of a full circle is 2 pi r or pi d, but we'll just use c for circumference for now. We can then times by what fraction of the full circle we have. So if we want to find the arc length of this bit here, then that's going to be x over, well, if we had all of the circle, that would be 360 degrees, so x over 360. Putting this in terms of the equations for circumference, this becomes either x over 360 times by pi d, or if you want it in terms of the radius, you could have x over 360 times by 2 pi r. You could simplify down this one a little bit, but it's easier to remember like this. It's just the circumference equation times by what fraction of the circle you have.